Welcome to CMS. So now we are going to the most distant place, to the most distant experiment of CERN, of LHC, that's CMS. CMS is in the exactly other side. So here in the other side of the street we have Atlas. That's one of the experiments. We say that Atlas people, they don't need cars because they don't just need to cross the street and they are there. Yeah. In our case, you see, it's a bit different. We have some kilometers to drive. And CMS is in the middle of nowhere. It's in the field. There is nothing. It's not like here. Okay. There is not a restaurant even. You have a coffee machine, a food machine, and that's it. Okay. So it's a different environment. You are in the countryside. Okay, so we go. So this is the car. Let's fit. CMS is in CC. That is a very small town, very far away from here, as you will see. I work for CMS since 2020, and I came here in the end of 2022. But before I was in Atlas. So I worked for Atlas for 5 years, and then I like very much to be here, to work here. Sometimes the weather is not as in Rio, but it's okay. I miss Rio as well, but for work here it's much better. It's the heaven for a physicist. It's a playground, you know. It's like a kid in Disneyland. And sometimes we stay working until really late because we love it. Not because we have to finish, we have to deliver, no. It's because we want to see things working, and we have the, you know, we are motivated to the project. So, and you have different people from different countries, different cultures, and they are very nice with each other. We have Chinese with Bulgarians, with Russians, with people from the USA, with Pakistanis people, with Indian people, with Brazilians, a lot of Brazilians, people from Georgia, people from, different places, and they are all working together. Italians a lot, and it's amazing. It's a level of collaboration that I didn't know that, you know, it was possible to do something like this. I am one of the technical coordinators of RPC in CMS. RPC is one of the Muon subsystems. And then we are responsible both for the maintenance and upgrade of the RPC chambers, which means that every time we have a problem, every time something is not working, we have to repair, or at least organize the repair with the proper expert. And also now we are installing 72 new chambers in the end caps. So it's a new generation of RPC with new electronics, everything is new. I mean, it's improved. The name is improved RPC, iRPC. And also this installation, the preparation for the installation, the cabling, everything is under our responsibility as technical coordinators. I also do some research based, because RPC, as I said, is a gas use detector. So, and the gas that we use is very aggressive to the environment. It has a high global warming potential. And now I'm also doing some R&D in alternative gas mixtures. I mean, I also have my analysis, the physics analysis. I'm searching for anomalous coupling. As I told you, there are, let's say, two main tasks: to measure precisely what we already know and to try to discover new things. I'm doing the first. I'm trying to measure with high precision the coupling between photons and W bosons. And this is something that the standard model already predicts. But, as I said, any deviation from this can indicate new physics. So it's very important, this measurement to be done. Sometimes people forget about it. They are focusing in dark matter, supersymmetry, magnet monopole, blah, blah, blah. And they forget that we have to measure very well what we already know. This is very important. When you measure something, there is a deviation, there is an error associated to it. If you decrease this error, you improve your measurement. And then at some point, with a big error, you can have one result that is compatible with your theory. But because it has a big error, so it's compatible with your theory and everything, you know? If you decrease this error, you're doing a more precise measurement, and you're confirming that the theory is more precise to foresee, to predict this. And at the same time, if now this is not precise, this is not compatible anymore, you can say that, oh, now the theory is not so good in predicting this. I mean, there is something else. The cavern was built 4 Siemens. In Atlas, there was already an experiment here before. In LHB analysis, the same. But for Atlas, for CMS, sorry, the cavern was built like 25 years ago to place CMS detector. We will see the pictures from that time. I mean, it's 100-meter underground, so it's a huge hole to be drilled. So another thing that's good that I can profit to explain now is that in CMS, in the underground, we have two caverns, two parts. We have the underground service cavern that we call USC, and we have the UXC, that is the underground experimental cavern, where the detector itself is. So during the year, where we are taking data, so LHC is accelerating protons, we cannot access the experimental cavern so often. For visitors, it's permanently closed during the year. Only during winter, when we have the called year-end technical stops, or YETs, then the technicians, the physicists, they can access the experimental cavern to do the repairs, to install new things, do all the upgrade, blah, blah, blah. And also visitors can access because the magnet is off, so it's safer. Where today we can only go to the USC, the service cavern, where all the electronics is, both electronics to power detectors, also electronics to read the signals from the detectors, the sub-detectors in CMS. These I can show you. That building in the middle of nowhere. Ah, nice view with Mont Blanc, huh? Atlas doesn't have this.
But LHB has McDonald's.
Yeah, true. to have lunch here. The options are like Bob's, McDonald's, no, Bob's on Burger King, McDonald's, Bob's is Brazilian. Burger King, McDonald's, that are, 15 minutes from here. Casting, I need your badge. You don't need it, only if the guy asks, you have to show him. Okay, good. And there we go. Welcome to CMS. The experiment itself is exactly here, underground, in this region, here. In this building, 3562, we have the meeting room here, the old control room that I will show you later, and now, here in the right, we have the new control room. This area was a parking in the past, and now, in few months, they did a brand new control room in a place where there was nothing. Here it is. We can enter here. I have to announce to the shift leader and technical shifter that we are going down, that there is a visit, everything. You can come. So they will not have to, so they will actually need Italian
Como é que vai? Tudo bem?
Bom,
Você é shift leader?
quer? Sou shift leader.
Eu tô com os visitantes aqui. Vou descer.
O que você precisa de mim?
Eu preciso não, eu tô avisando só.
Ah, tá bom.
Conhece esse cara aqui?
Tudo bem? Tudo bom? E aí?
Hello.
Hi.
I'm Thiago. Nice to meet you.
I'm Sven. Hi.
He's the shift leader.
Yeah, I'm the shift
Explain to them in 5 words what the shift leader does.
He's also from Brazil.
I'm also Brazilian.
We are everywhere.
You know, this thing is becoming the associate member. In 5 words, I try to implement the plans from the run coordination while trying to adapt to the chaotic scenarios that usually happens in the LHC.
So remember that I told you that we have LHC with a proper control room with their plans, and and then here in this control room, in this room here, we have the shift leader plus the technical shifter, I think it's her, and they have to adapt what the run coordination of CMS wants to do in the day, which kind of data they want to take with LHC plans. So this is the work, and they are here 24 hours per day, 7 days in the week, in shifts, 8-hour shifts. Okay, so now they are still changing. So here you can see beam setup, no beam in this screen, which means that there is no beam in the LHC in this moment. So all the news, let's say everything from LHC, we see in this screen here, and here we can see the status of the detector in the experimental cavern. Okay. So you see there is a lot of work in progress still. We are waiting we are supposed to have this information from the accelerator, from LHC, in big screens in the wall. Then it's more, you can see from everywhere. Because also, you see another tables in the other part. There, each table is for a subdetector. So CMS, I will show you, is like a onion, a cylindric onion with layers. Each layer is a kind of detector. And each subdetector has a table here to inspect its own subsystem. So there is an expert sit there for every subsystem to follow it. So if there is an alarm here, they go, oh, something is happening, and then there is an expert that try to solve it. If it's something in the experimental cavern, we have to book a moment where there is no beam to do an access. So a lot of things to do. Take the data, ensure that the data has a high quality data. We have to ensure that the access is done in the proper way with the safety, no radiation. We have to ensure how many people are underground, when they are going, when they are supposed to leave. A lot of responsibilities. Most of these, of course, we share the responsibility, but shift leader is the head. I mean. We will start the visit from here. So let's go to the cavern. We are coming here in the service cavern. Here we have the USC. Here we have the UXC. So we are going here. Service cavern. A lot of electronics and blah blah blah. And a bit of magnet field. Here, unfortunately, we cannot access. You have to come back in winter. Then we can go there. Let's go.
CMS ist das kleinere von den beiden Experimenten. Also CMS und Atlas, die beiden großen Multipurpose-Detektoren, von denen ist CMS das kleinere Experiment. Es hat ein größeres Magnetfeld, was dazu sorgt, dass die Spuren sehr viel enger gekrümmt sind. Und ich kann die halt auf einem kleineren Raum nachweisen als bei Atlas. Atlas hat den Vorteil, dadurch, dass er jetzt größer ist, die Spuren nicht so stark gekrümmt sind, dass ich einen sehr viel größeren Hebelarm habe. Wenn ich die Spur vermesse, werde ich dadurch sehr viel genauer.
Exactly. So as you see, most of CMS is muon chamber. So the red part actually is yoke, so it's lead. But between these red parts, it's muon chambers. Because the muons, they have a very clear signature, because the only kind of particles that can go outside the magnet are the muons. So, of course, neutrinos as well, but neutrinos you don't see them at all. They go, you don't measure. Muons you measure, and they are the only ones that go in this red part, the red region. So they are very, very important. That's compact muon solenoid. The last very important discovery here was the Higgs boson 12 years ago. That is responsible to give the mass of the particles. So there is the Higgs field where all the particles are, and the particles that interact with this field have mass. And the particle associated to the field is the Higgs boson, discovered here 12 years ago. So, but okay, I will go inside, then this will open, you enter, okay? Something very important about helmets is that you cannot remove them, especially when you are going to enter or go outside in the lift, because there is a camera that is counting people. So when we access, they count you. So this is a very important place, the lift. CMS is the only place in the whole world where the emergency exit is a lift. So if there is something burning out downstairs, we run to the lift. Usually we say that the lift is the safest place in the world. So, and here you can see that we are in the minus 87.9 meters. The detector is in minus 100. This is minus 2, is the service cavern, as I told you. In the minus 3 is the experimental cavern. And it's not like this and this, it's like this. So the experimental cavern actually it's half floor down. So now we will enter where all the electronics is. Be careful with this scaffolding. Two very nice things to show here. First, all the process of creating CMS. So the detector is assembled in the surface, then it comes down from here. If you can see, it goes from the surface and here is the experimental cavern. Can you see this plug there? The cavern is exactly there. It's this wall in the other side. So the detector comes from here on top and then enters there. You can go here. So here it's very noisy because the detector is on. So in these corridors we have high voltage, low voltage, and everything that needs to power the detectors. Every 25 nanoseconds there is a collision. Do we save all this data? No. We see which parts of the detector are seeing something. What's interesting, we save. What's not interesting, we don't save. So here we have the first step in this chain. So here we can see that each rack is for one subsystem. So ECAL is the electromagnetic calorimeter, one part of the layer, one of the layers in the onion. DT, CSC is there are the detectors placed in the Muon chambers. The Muon chambers we have 4 different detectors: DT, CSC, RPCs where I work, and GEMS that are the new ones that are someone already installed, the other one will be installed, but they will start taking data for physics after the long shutdown is starting in 2026. So there is a long shutdown, that's 3 years where the detector is off for upgrades and repairs. And then all GEMS will be installed and they start taking data in 2029, in the new phase of LHC. Right behind this door is the LHC. To go there, we have to use a bag like this. You can breathe for some minutes and exit safely the area. So here a real size picture. And right behind this wall, it's CMS detector. Magnet is on, so here we can see. So they are not like this, they are like this, because there is a magnet here. Something that people sometimes they don't understand is that we accelerate one proton and one proton. No, you accelerate bunches of protons. And each bunch has 10 to 11 protons. And the number of bunches are 2,808. So each bunch crossing, we have this number of protons, not colliding, but crossing. And then one or more, sometimes more, they collide. And then near the collision region, we have the tracker. First layer of detector in CMS, close to the interaction point, and the tracker will measure the path, the trajectory of the charged particles. Then, with this trajectory, you can do extrapolation and see where it comes from. So which vertex. And then you can reconstruct what happened in the collision. The magic of CMS is more or less like this. And CMS is exactly underground. It's exactly here. This floor is a movable floor. Because the detector was assembled here in this garage and lowered down here. So the magic also can happen here. In the LS3, they are going to remove two discs, minus and plus one in the end cap from here, leave it here, put the new one down. So a lot of work. 3 years of shutdown, no beam, access, and we will have a new detector, let's say. Very upgraded detector. And that's it from my side. Questions?
You see the cranes? These are the cranes we saw today in the gateway.
Yeah.
Where you had to put the.
Yeah.
So they have this little toy where 4 people on wheels can steer 4 different. Can lower it down. It's very nicely done.
Nice. Exactly. We have we have the cranes here, and also underground. We have 2 cranes in 2 sides. So you have the moment when you lower down, you put it there, and then the other crane comes to do the local maneuver, let's say. So it's a very complex thing. This shield here, I would say it's old, but outside I can show you the new shielding for the forward part. Let's go, I show you the new shielding outside. So, it's very funny. Here it is. This is the new shielding. And then we saw they lowering this down. It was very fun. To see a baby like this, going down from the surface to underground. It's very nice. I go the other way around. I'm afraid to leave the border, so we can go back. Same way we came. And now there is a very nice view. Very nice view. We go right. Here, don't need a badge.
What motivated you to go into science?
Long story. When I was in the high school, in the last year, I had a teacher of philosophy, and there was an exam. I remember that it was something related with Habermas and some modern philosophy and things like this. That I'm sorry, I forgot. But the last question was like, what do you want to do for your life? And you know, I'm from the countryside of Rio. I didn't know about science. I better knew about
CERN and I mean things like this, only from Dan Brown's book maybe. And then I replied to this question saying that I want to be engineering, a mechanical engineering, because I'm good with maths and because I want to go to the center of Rio to study in a good university, and that was the dream I had at that time. And okay, I replied like this, and okay. And then in the end of the exam, he took the papers, and I was like setting up my things to leave, and he was like, we need to have a chat. And I was like, oh my God, I'm sorry, I didn't study that much, I had no time to read about Habermas. And then he said, no, it's not related with Habermas, don't worry. And he said something like, are you crazy? I'm sorry, I like philosophy, but I don't see myself like doing philosophy. And he was like, no. The point is that you're not engineering, you're a scientist. You're a scientist. Because I went to the lab of the school to do the same things, the same experiments like 10, 20 times until it worked. And then I had this, persistency to repeat, to understand why it's not working. It's scientist. It's a scientist behavior. And he opened my eyes to this. And then I was introduced to Marcia Begali, that is a physicist at Rio de Janeiro State University, the university I am until today. She's working in Atlas. I fell in love for physics. And then in the next year I started doing physics there. And I started working with her. I stayed with her for 5 years. Then I moved to CMS in the master, and now I'm in the PhD inside CMS. So to summarize, I like to study and I like to discover things, even minor things. I mean, last discovery from CMS was Higgs boson 12 years ago. I'm not here to discover supersymmetry, dark matter. I mean, of course, we have to search for it. This is very important nowadays. But I don't want the Nobel Prize. I like to do the experiment by itself. Like the nature of discovering is good by itself. We don't need to do big things, huge things to be happy. There is not this, oh my God, we don't discover anything for 12 years, we are not useful. If you think about this in this way, we are dead. We have no work. In 10 years, we are all doing something else. You have to think science as something that the discoveries, you do it day by day. Here you are. De nada, Castro. You're welcome. It was a big pleasure. Pleasure is mine. Hope to see you again.
Obrigado.
De nada. Eu que agradeço. Sábado a gente...